In 2025, Florida started putting robotic rabbits into the Everglades. Not cameras, not traps. Machines built to look like prey, wrapped in real rabbit fur, heated to the body temperature of a living animal, and programmed to twitch. Each one cost around $4,000. Reporters called it a stunt. Commenters called it a waste of public money. Plenty of people looked at a solar-powered toy bunny sitting in a swamp and concluded that Florida had finally run out of ideas. They were half right. Florida had run out of ideas. That was the entire point. Because everything sensible had already been tried, for 25 years, at a cost of tens of millions of dollars. And the thing they were fighting had already eaten almost every mammal in a national park. The decoys worked. Within months, they were pulling pythons out of the sawgrass at coordinates nobody had been able to search, and generating data on the animal that no researcher had ever collected. But they did not do the job the headlines said they did. And the reason why is the actual story. The Burmese python is not supposed to be in Florida. It is native to Southeast Asia, where it belongs to an ecosystem that evolved alongside it. How it arrived is partly the exotic pet trade. Through the 1980s and 1990s, Burmese pythons were sold cheaply as hatchlings. A hatchling is charming. An adult is a 15-foot animal that eats deer, and owners released them by the thousand once the charm wore off. The other part is Hurricane Andrew. In August 1992, Andrew crossed South Florida as a Category 5 and destroyed a reptile breeding facility near Homestead. Nobody knows exactly how many snakes went into the swamp that night. The estimate is a lot. Either way, by around 2000, there was a confirmed breeding population inside Everglades National Park, and the conditions were close to perfect. Warm year-round, wet, enormous, and containing no animal capable of eating a full-grown python. Then came the part that still shocks biologists. In 2012, researchers published a road survey study comparing mammal sightings across the Everglades before and after pythons established. The numbers were not a decline, they were a collapse. Raccoon observations fell by roughly 99%, opossums by about 99%, bobcats by about 88%. Marsh rabbits, cottontail rabbits, and foxes were not reduced. They were not seen at all. An entire tier of the food web had been removed from a national park by an animal that had been there for barely a decade. And pythons are extraordinarily difficult to find. They are ambush predators built for stillness. Their patterning breaks up their outline in sawgrass so effectively that experienced searchers walk within a meter of a 12-foot snake and see nothing. They spend long stretches submerged or under vegetation. A python that is not moving is, for practical purposes, invisible. There is one more thing that makes them almost impossible to manage. A large female Burmese python can carry 50 or more eggs in a single clutch, and she guards them until they hatch. Remove a male, and you have removed one animal. But leave one breeding female in place, and the population replaces everything you took, inside a season. That asymmetry is why the removal totals never seem to matter. 20,000 snakes sounds decisive. However, if the breeding females are still out there in the sawgrass, the number is close to meaningless. That is the problem Florida has been trying to solve ever since. Not killing pythons. Killing pythons is easy. Finding them is the hard part. The first approach was people. Florida began paying contractors to hunt pythons, on an hourly rate plus a bounty scaled to the length of the snake. It works, in the sense that removals happen. Over 20,000 pythons have been taken out of the ecosystem, but scale defeats it. Everglades National Park alone covers around 1.5 million acres, and the wider python range is larger still. A hunter walks a levee road at night with a flashlight and covers a strip a few meters wide. The arithmetic is brutal. Then came the public competition. The Florida Python Challenge, launched in 2013, invites the general public to hunt pythons for prizes over about 10 days. It draws roughly 1,000 participants a year and generates enormous press. It also demonstrates the problem better than any study. 1,000 people, sweeping the Everglades for 10 days, typically remove somewhere around 200 snakes. Against a population estimated in the tens of thousands and possibly far higher, that is not control. It is a rounding error with a trophy ceremony. Detection dogs came next, and they genuinely help. Dogs trained on python scent can find snakes that human searchers walk straight past. However, dogs cannot work long shifts in Florida heat, they cannot cross deep water safely, and they cannot be scaled to millions of acres. The cleverest method was the scout snake. Researchers capture a male python, fit it with a radio transmitter, and release it during breeding season. The male does what males do. It goes and finds a female. The team follows the signal and removes a breeding female, which is worth far more than removing a male, because a large female can carry dozens of eggs. It is elegant, but it also requires you to already have a snake, and every scout you deploy is one you caught the hard way first. Every one of these methods shares a single weakness. They all depend on a human being physically present in the right few square meters at the right moment, in a wetland the size of a small country. Which raises an obvious question nobody could answer. What if you did not have to be there at all? The idea did not begin with robots. It began with live rabbits in pens. Researchers at the University of Florida ran an experiment to test something simple. If you put marsh rabbits in enclosures out in python habitat, do pythons come? They came. The pens attracted pythons reliably enough to prove the principle. A python will travel toward a rabbit it can detect. That single result reframed the whole problem. Instead of searching 1.5 million acres for a hidden animal, you could make the animal come to a known point. But live rabbits are a nightmare operationally. They have to be fed and watered daily. They get sick. They die. They are animals in cages in a swamp full of predators, and the ethics are uncomfortable. Nobody was going to scale that across the Everglades. So the question became, what exactly is the python detecting? The answer turned out to be a short list. Heat, primarily. Pythons have heat-sensing pits along the jaw that detect infrared radiation, which is how they hunt warm-blooded prey in total darkness. Motion, smell, and that is close to it. None of those things require a living animal. A python is not identifying a rabbit. However sophisticated the hunt looks, it is responding to a warm, twitching shape that smells approximately right. The build was led by wildlife ecologist Robert McCleary's group at the University of Florida. They took toy rabbits, hollowed them out, and rebuilt them. Inside went a heater to hold the shell at roughly the body temperature of a live marsh rabbit. A small motor produced intermittent twitching movement. Real rabbit fur went on the outside. Solar panels and a battery kept it running unattended. Around 40 units were deployed in the first phase, across python habitat in South Florida. Not hundreds, despite how the story was reported. But the design is modular and cheap to replicate, and scaling up is a budget question, rather than an engineering one. Then came the part the design actually turned on. Each decoy carried a motion-triggered camera. When something approached, the system sent an alert. That meant a removal team did not need to be in the swamp waiting. They needed to be reachable. That is the inversion. 25 years of python control had been humans searching for snakes across an area too large to search. The robot rabbit flipped it. The snakes come to fixed, known coordinates, and the humans arrive afterward. Each unit costs around $4,000, which sounds expensive until you compare it to a contractor walking levee roads all night. A robot works every night, in every weather, indefinitely, without a wage. And there was a benefit nobody designed for: the decoys record. Every approach, every visit, every animal that comes to investigate gets logged with a time and a location. A program built to catch pythons started generating a continuous data set on how pythons actually move, when they are active, what conditions bring them out, how far they will travel toward a target. That data does not exist anywhere else, because until now nobody had a way to reliably observe a python that had not already been caught. And the decoys do not only attract pythons. Bobcats come, raccoons come, birds of prey come. Every one of those visits is another record of which native mammals are still present in a given patch of Everglades, which is information Florida has been guessing at for 2 decades. That was not the point of the program. But a network of heated, camera-equipped decoys scattered across a wetland turns out to be a census tool as much as a trap, and it is running continuously in places no survey team visits. Now the honest part, which the headlines mostly skip. The robotic rabbits do not kill anything. The name promises a machine that hunts pythons. What it actually is a very good doorbell. It is a detection and monitoring tool. A python still has to be removed by a person who drives out and does it by hand. And as of now, the deployment is a pilot, around 40 units in a landscape of 1.5 million acres, against a population that may run into the tens of thousands. Do that arithmetic honestly, and the picture is sobering. Even a wildly successful expansion to hundreds of units does not eradicate Burmese pythons from South Florida. Most researchers working on this will tell you plainly that eradication is no longer on the table. The realistic goal is suppression, holding numbers down in priority areas, protecting whatever mammal populations remain. There are also unknowns nobody has answered yet. Whether pythons learn to ignore a decoy that never turns into a meal, whether the units survive alligators and storms over years rather than months. There is a harder question underneath all of it. Suppression is not a project with an end date. It is a permanent cost. Staff, equipment, replacement units, funding renewed every budget cycle, forever. Stop for a few years, and the population recovers whatever ground you took. Most conservation spending is sold as a fix, but this is closer to maintenance on a building you can never finish. Florida did not deploy robotic rabbits because it was a brilliant idea. It deployed them because 25 years of sensible ideas were losing, and the mammals were already gone. The wider lesson is about timing, not technology. A breeding population of pythons was confirmed in the Everglades around 2000. Serious, funded, coordinated control did not arrive for years afterward. In that gap, the population expanded across an area that can no longer be cleared. That is the pattern with almost every invasive species disaster. There is a window early on when removal is cheap and possible, and it closes quietly before anyone accepts that the problem is real. Once it shuts, the tools stop being about elimination and start being about damage limitation, forever, at permanent public expense. The robot rabbits are what the far side of that window looks like. Ingenious, genuinely clever engineering, deployed a quarter of a century too late to win. Florida released robotic rabbits to kill pythons, and what nobody expected was that they would not kill anything at all. They were never weapons. They were an admission that after 25 years, the only workable move left was to stop looking for the snakes and let the snakes come to you. The Everglades will not get its raccoons back. It might get to keep what is left.